There are two bases that are used so frequently that we give them their own names and special notation. The first is the base 10 log. We use a base 10 number system, so base 10 is very important. When no base is specified after the log, it is understood to be a base 10 logarithm. So if we look at y equals log 100, we know that with that no base indicated that this is really y equals log base 10 of 100. We just don't write the 10 in there, but it's understood to be a 10. So if we convert this to exponential notation, we get 10 to the y equals 100. Converting this to a common base, we get 10 to the y equals 10 squared. So y equals 2, or log 100 equals 2. Likewise, if we have y equals log of 1 over 100, this is understood to be a base 10 logarithm because there is no base indicated. So we can think of this as being y equals log base 10 of 1 over 100, even though we wouldn't write it this way, we can think about that 10 being there when we look at it. So when we convert this, we get 10 to the y equals 1 over 100. And we write this in terms of a common base, gives us 10 to the y equals 10 to the negative 2. So y equals negative 2. So log of 1 over 100 equals negative 2. There is a very special irrational number that has uses in natural sciences, business, finance, population growth, and so on. We call that number e. This base gets used so much, we give it its own notation. So the natural log of x is the name of this. The natural log of x is equal to log base e of x. So whenever you see ln of x, you know that that's a log with base e, where e is approximately equal to this number over here. So if we start off with natural log of e to the fifth, we put a variable next to that, so the natural log of e to the fifth, and we realize that, oh, this really means y equals the log base e of e to the fifth. So when we convert that to exponential form, we get e to the y equals e to the fifth. So y equals 5, meaning the natural log of e to the fifth equals 5. An only slightly more complicated problem would be the natural log of e to the 2x squared plus 5. So we write this as y equals natural log of e to the 2x squared plus 5. And we keep in mind that this really means log base e. So y equals log base e of e to the 2x squared plus 5. So when we convert this to exponential form, we get e to the y equals e to the 2x squared plus 5. So y equals 2x squared plus 5. So the natural log of e to the 2x squared plus 5 equals 2x squared plus 5.